Hello everybody and welcome to my channel analysis. In this channel we will deal with some concept in analysis as differential equation, integration and function with multiple variables and other topics which are so interesting, and we will solve some exercises also. And in this lecture, we will start with differential equations since they are one of the interesting topics that I want to teach you, or just giving you an information since it's the existence of uh, these topics is from the centuries. So we will start with a differential equation. We will know what does a differential equation mean, what does a degree in the order of differential equation, and we will give some classification of some differential equation and some methods, some techniques how to solve them, and let's get started. Well, we will start as I told you by differential equation. A differential equation, which is an equation involving a function and its derivatives, involving a function and its derivative, and it is noted by f of x, y prime, y2 prime, until y the nth derivative, yes, is equal to 0. This is the notation that we use in a differential equation. And this solving a differential equation means finding the function that satisfies this equation. We need to find y that satisfy this equation. Okay. Now, what does the order and the degree of a differential equation? When we say the order of a differential equation means the highest derivative in the equation that we have. For example, Uh, let me just write it down. The order of a differential equation. Differential equation is the highest derivative that we have in this equation. For example, x2 prime, y2 prime, sorry, plus y prime plus y plus x squared ln x is equal to 0. The highest derivative in this equation is y2 prime, so it is the second derivative, so the order is 2, which is the second derivative. Another example, y prime to the power of 5 plus y2 prime, y3 prime, sorry, to the power of 5 is equal plus 10 is equal to 0. And in this example, we have the first derivative and we have the third derivative, so it is the third derivative. So it is the third derivative, and so the degree, the order is 3. Let's see another example. We have y prime, y2 prime, sorry, to the power of 5 over 2 minus y prime to the power of 2 is equal to 0. In this example, as you can see here, we have the second derivative raised to the power of 5 over 2, and here we have the first derivative raised to the power of 2, so which is the highest derivative, so the order right here is 2. Now we need to know another concept, which is the degree of a differential equation. The degree of a differential equation is just the highest power of the highest derivative. So it is the highest power of the order of a differential equation. Keeping the same example, dealing with the same example, we will get that we have y2 prime plus y prime plus y plus x squared ln x is equal to 0. As you can see here, this is the highest derivative raised to the power of 1. So the order right here, the degree right here is 1. Okay. The second example, y prime to the power of 5 plus y 3, which is the third derivative, power of 5 plus 10 is equal to 0. So right here we said that this is the highest derivative, which is raised to the power of 5. So it is the degree of this equation is 5, just 5. Let's see the third example, which is y2 prime all to the power of 5 over 2 minus y prime to the power of 2 is equal to 0. As I told you before, this is the highest, which is y2 prime, which is the second derivative, which is raised to the power of 5 over 2. We cannot deal with that, so we will rewrite it in another way, which is y2 prime to the power of 5 over 2 is equal to y prime to the power of 2. By raising both sides to the power of 2, we will get y prime to the power of 5 minus y prime is equal y prime to the power of 2 times 2, which is times 4, and it's going to be y2 prime to the power of 5 minus y prime to the power of 4, so is equal to 0. In this equation we can see this is the highest derivative and it is raised to the power of 5, so in this equation the degree is 5 and the order is 2, as we said before. And this is all what we need to know as a terminology in a differential in the concept of differential equations. Now we will see some classification of a differential equation of the first order. When we say the first order, as we did before, the order is the highest derivative. So the first order, so in our equation, we will have just f of x by y prime is equal to 0. This is for the first order differential equation. We will see some classification as a linear differential equation, homogeneous and separable, exact and non-exact differential equation, etc. We will see a lot of them, and we will start one by one since they are easy. So let's get started. Let me just see if it's recording or not. Sorry. Oh, yeah. Let's see the first one, which is the separable differential equation. Let's see the separable differential equation, and any differential equation written in the form of mx dx is equal to, or we can just say minus or plus ny dy is equal to 0. Any differential equation is written in this form, so it is a separable differential equation. Just a remark that dy over dx is the first derivative. Just a remark. I know that you know this information before. And let's see it in another form, since some people can see it as what I have wrote right here, and other can see it in another way. So it's gonna be mx is equal, let's see it as a derivative, dy over dx, which is the first derivative. Let me rewrite it here, which is the first derivative, is equal to minus, it's not necessary to write a minus, mx over ny. Yes, this is another way you can see it, and another way we can just rewrite it as a ny y prime is equal to minus mx which is another way. Some people can see it as this, this form, and other can see it in this form. To make things clear, we will give some examples to make sure that you have understand, and they are a simple example, and we will in the course, just in the course, to to be familiar with these exercises. And all these example we will be solving the differential equation of in separable ones. Okay, let's get started with the first one. It said solve the differential equation, which is 4xy dx plus x squared plus 1 dy is equal to 0. As you can see here, we have something is multiplied by dy, which is something, it's not ny, which is like mx, and something is multiplied by dx, which is dx, and 4 we will keep it aside, and we will have y, so we need to remove this y. What should we do is to divide all the equation by y. We will get 4x dx plus x squared plus 1 dy over y is going to be equal to 0, and we will remove this quantity, or just dividing all the sides by x squared plus 1, we will get 4x over x squared plus 1 dx plus 1 over y dy is equal to 0. Now I didn't finish the explanations right here, so we will do more explanation in this example. So as you can see, we will write this equation in another form. We will keep aside everything that is related with x in a side and everything that is related to y in a side. It's going to be 4x over x squared plus 1 dx is equal to minus 1 over y dy. So this is all about x's and this all about y's. So what should we do right here? We should just integrate the both sides to get our answer, since we have got a function with respect to x and the other side is a function with respect to y. By integrating, we will get our solution. So the solution of this is what we have. We have 4x over x squared plus 1, which is 2 ln the absolute value of x plus 1. It's not necessary to put the absolute value since the quantity is always positive, x squared plus 1, and plus c, we can write plus c1 is equal to minus ln the absolute value of y plus c2. Right here, c1 plus c2, we will replace them by c. We can just write a c plus c is equal plus c, and we have ln x squared plus 1 to the power of 2 plus ln the absolute value of y is equal to c. So we will get ln absolute value of x squared plus 1 squared y is equal to c. So by using exponential function, we will get x squared plus 1 all squared y, and the absolute value is equal to exponential c, which is going to be a lambda or something, some parameter, since it is a real variable. This belongs to r plus. So we will get x squared plus 1 all squared times y is equal to lambda. So thus means that y, we will equal to plus minus lambda, that, and this is belongs to R, since lambda plus lambda is belongs to R plus and minus lambda belongs to R minus. So we will get that y is equal to lambda plus minus lambda, or we can just write it as another parameter, which is gamma or something, over x squared plus 1 all squared. This is our solution for this differential equation. And if you want just to verify if it's satisfied, we just need to get the derivative of this and replace it right here, and we will get our answer. Let's see another example, and this is the first example. Yes, let's see the second example, and they are all easy examples, just to get the concept of differential equation. It says that 1 over cosine y dx plus 1 over sine x dy is going to be equal to, here it's going to be my dx, it's something related to y, times dx plus nx or mx with respect to y is equal to 0. In this situation we have my, so we need to get an x into this side. So just we need to divide and we will get our answer, or just here multiply by, let's see this example, or just here we can just multiply by cosinus y, we will get, and sine, we will get sine x dx plus cosine y dy is equal to 0. By integrating the both sides, what we will get, the integration of sine is minus cosine x, and here the integration of cosine is sine plus sine y is equal to c. So what we will do, we will have sine y minus cosine x is equal to c. In this step, this is a solution for our differential equation. It's not necessary to get a y in a side and everything in another side. Sometimes we can do that, and some we cannot. It's going to be c plus cosine x, and here we need to see the domain of y. The domain of y, we need to see if this quantity belongs to minus 1 and 1, since to use the function f of y or x is equal to sine the inverse of sine x. So we need to see if this quantity belongs to minus 1 and 1. And this is not necessary, since they didn't say to find the domain of definition or something. We can keep it as it is. And this is our solution. Yes. Let's see another example. What we have, let's see it by the argument and the distance, and this is in geometry. Yes, we will have tangent theta dr plus 2r plus 2r d theta is equal to 0. In this example, we have m theta dr plus nr d theta. So what should we do? We just need to divide here and plus, and here 1 over tangent theta is equal to 0. Now by integrating both sides, what we will get? We will get 1 over 2 ln absolute value of r plus the integration. As you can see, 1 over tangent is 1 over tangent theta is cosine theta over sine theta, and by integrating both sides, since the integration of this, and as you can see here, the cosine is the derivative of sine, so we will get ln sine theta plus c, and we will replace it here. Ln the absolute value of sine theta is equal to c. And you can do some simplification for this, and you can keep it as it is. We just need to multiply by 2. What we will get? We will get ln absolute value of r plus ln 2, which is 2 ln sine theta is equal to 2c. Let's write it as a lambda. And right here it's going to be ln the absolute value of r times sine square theta, okay, is equal to lambda. If we are dealing with a distance, so r is always positive and sine squared is always positive, so we can remove the absolute value. Okay, this is a remark. The second remark, we can use an exponential function to get a r by itself, like we will get r times sine square theta is equal to exponential lambda. We can write it as another parameter, which is gamma. And the solution of our equation, which is r is equal to lambda, sigma over sine square theta. And as you can see here, we have just to see where theta belongs, and that it's not a bigger problem. We can deal with it later, or you can just try to do it. And let's see another example. Yes, and maybe it's gonna be the last example, or maybe not. We will see later if it's gonna be. What we have, sorry, I need to see what I have did. We did this example. Yes, and this. Okay, let's see this example, and which is quite easy, I think. It's gonna be dy over dx, dy over dx minus x squared plus 1 over y squared plus 2 is gonna be equal to 0. As you can see here, it's going to be like dy over dx is going to be equal to x squared plus 1 over y squared plus 2. Sorry. And what should we do now? We will get, sorry, we will get y squared plus 2 dy is equal to x squared plus 1 dx. By integrating both sides, we will get our solution. We will get 1 over 3 y to the power of 3 plus 2y plus c. We can keep it aside. And here it's going to be 1 over 3x to the power of 3 plus x plus c. And this is going to be our solution. We can now just do some simplification. Plus 2y minus 1 over 3x cubed minus x, minus x is going to be equal to c, and this is our solution for this example. When we get the derivative, if we want to just confirm if it's the right solution, we can just replace it in this in this equation. So I want to just give you a remark how you can find, we have been talking about how to solve a differential equation, and it's something important to know that how to find the differential equation. Let's get an example for it. And as we said, we can just do the inverse steps that we used here to get our equation, to solve our equation, sorry. Here we can just get the derivative of this equation. So when we get the derivative, we will end up in this form. Yeah. So let's see an example, which is this is going to be the fifth. We can see another example. Yes. Let's see that y is equal to c exponential x. This is our equation. Let's try to separate all of these. I'm gonna give you two methods, and one of them is uh, is better than the other one. So here, by getting the derivative, we will get dy prime is equal to c exponential c. Yes. As you can see, this is the same as this, so we will end up with y prime is equal to y, and it is the same as y minus y prime minus y is equal to 0, or y minus y prime is equal to 0. To solve this equation, we just need to write it's going to be dy over dx is equal to y, so is equal to y, so by multiplying we will get 1 over y dy is going to be equal to dx. By integrating both sides, we will end up with ln y is going to be equal to x plus c, and here y absolute value of y exponential x times exponential c, and this is a parameter lambda. We will end up with y plus minus lambda exponential of x, and this is the right solution that we start with, which is this one. And there is another method how to solve it every time. We will put a constant in a side. Since this is the constant as this, we need to put it in a side by itself. We have y is equal to c exponential x, so it's going to be y times exponential minus x is equal to c by itself. Yes. And this time we need to get the derivative of two sides, so it's going to be with respect to x. Yes, it's going to be y minus x over dx is gonna, this is with respect to x, is gonna be 0, since the derivative of any constant with respect to a variable, which is 0. And this time we need to get the derivative of this. The derivative of this with respect to x, since y is with since y is our function, so it's gonna be the product of two functions, which is y prime times exponential minus x. Yes. And the derivative plus the derivative of this exponential minus x, sorry, the derivative times y is going to be equal to 0. Here it's going to be y prime exponential minus x, and the derivative of this minus exponential minus x times y is equal to 0, and is going to end up with this. We will get y prime minus y is equal to 0. As you can see right here, it's the same equation, y prime minus y is equal to 0, and y prime minus y is equal to 0. Yes, this is a method how to find, sorry, a differential equation. You can try it by yourself, and it will be easy when you practice on it. And how much constant do we have? I just want to give you a remark here. How many constant do we have in this equation? We have just one constant, so we need to get the first derivative, only the first derivative. But if we have a two constant or more than two, in the addition or in the addition of the or a subtraction, we need to get the first and the second and the third, how many constant, how many derivative that we need. You need to keep this remark in your mind. And this is all for today. I hope you enjoyed. You were with Ali, and see you in the next videos.